Greetings fellow fixers, it is I, Mark from Mark Fixes Stuff, and today we're going to do something pretty exciting. We're going to burn some stuff with a frickin' laser. Yes, this is the AlgoLaser Delta, a 20 or 22 watt laser cutting machine depending on the source you read. Now I'm not going to lie, I literally know nothing about laser cutters. I don't know how to set them up, I don't know how to install the software, I don't know what software they use. I don't know anything about it. So I thought what we'll do is we'll open it up, set it up, and I'll react to it in the only way that I know how. Honestly. We're going to put it together. We're going to see what it does. We're going to burn some stuff with a frickin' laser. And we're going to do it right now.
Mark Fixes Stuff.
This channel is sponsored by PCBWay, and they don't just do PCBs. If you want professional 3D printing, just upload your models, pick from a variety of materials and colours, and you're on your PCBWay. Thanks to Elaine and the PCBWay team for supporting Mark Fixes Stuff. Let's get the box open. It feels really well packed. I wasn't really going to do a setup video, but I've been told that this is quite an easy machine to put together, so I thought we'd go through that together. Also, we'll be able to see what's in the box. So we've got a consumables package, some kind of tribute to Lionel Richie. Hello, is it me you're looking for? And a nice note thanking reviewers for having a look at their product. Well, we'll see about that. There's also this package, which I suspect is full of manuals. First out of the gate, we have a certificate of conformity, and this one is for the laser module. There's another certificate, and this one's for the laser safety glasses, and I guess we'll have to take their word for it. A leaflet about after sales. Quick start guide for the air assist pump. And a quick start guide for the laser engraver itself. I have to say the manual is actually laid out really well, and we could have saved ourselves a job by going to this straight away. So let's just get rid of all this box litter. In the middle of the box there's a random piece of bowed wood. I guess this is a sample as well. Now I'm not sure if the part in the middle is meant to come up and there's something inside, or that's just a part of the packaging. Let's just tug it off. Oh wow. In order to get to the contents better with the camera, I cut a bit of the box off. Massive flaps can really get in the way sometimes. So, now we're in, let's have a look at what's in store. We've got a pair of safety glasses, I assume. Oh, in 1990s orange. I like that. Like I say, there's a certificate saying that these are safe, and I just hope it's true because how else would I know? They do look pretty funky though. I might wear these to the local rave and get down with the kids. We also have a USB-C to A cable, some kind of hose, presumably for the air assist, and a mains cable which I assume will go into the massive power brick that they've supplied. The mind actually boggles. What's that? It doesn't look very happy. I'm not happy! And a bit of wood for later toasting. That's quite thick. Something else on the thick side is this huge lump of acrylic. My goodness. Apparently the laser can cut through this in one pass, but we'll concentrate on thinner stuff today so I don't stink out the lab. And talking of thinner stuff, inside this box we find some other useful items. There's a black metal credit card, I think. Another acrylic sheet, this time a bit thinner and a slightly larger size. Cable tie. A bit from the back of your mum's IKEA wardrobe. Well, I suppose it's useful. Yet more cable ties. And a piece of metal that's very reflective, and isn't that quite worrying with the laser? I'm not sure. And that's that. So, turning our attention to the contents of the box, we pull out this little toolkit. Inside we find the few screws and bits and bobs that we need. Let's whip it together in conjunction with the manuals. We'll start with this one, moving on to the air pump afterwards. The manual really is a high quality effort. It lists all the items that you should have and also tells you how to put it together, with the first step being removing everything from the box. I shouldn't have bothered cutting that flap off really. It took me ages to find that craft knife as well. Oh well. At least we can get the box all of the way out of the way, and then we'll have a clearer area to work in. In case anyone's wondering, I chose this black tablecloth for its unique ability to show up cat hair and dust. It's time to admit that I really didn't know the scale of this machine before I unboxed it. It's huge. Of course, I'd seen the dimensions written down, but in reality, it's bigger than I ever could have imagined. The instructions tell us to take out this chunk of foam. Let's just put that to one side. We're instructed to take out the laser module and install the air assist nozzle. It's meant to go in here. I'm guessing it's the thing that we saw in that box. That does look suspiciously like it. Let's see if it fits. And fit it does. With the multiple threads taking quite a while to screw in. I don't suppose this is going to fall out in a hurry. With the air assist installed, the next part is to mount the laser module on the X-axis. And the X-axis is this long bit that will go left and right over the top of our laser cutter. Right, how does this go on then? It slides in on rails, and where this is handy is that you can raise and lower it and lock it in position. And with the laser module locked in place, it's really secure. So that's that bit done then. For the next part, if you lock the laser too low, you won't be able to line up the 4 screw holes that you need to mount the X-axis on the machine itself. You can unlock the lever here and raise the laser assembly head so it's higher, or you can do what I did and just take it off the frame entirely. This way the X-axis isn't trying to fall forward under the weight of the laser head, allowing you to line up those holes more easily. There's 2 machine threaded screws that need to be put into each side of the X-axis. Looking at the manual, they're M4 by 10 screws, and it's the same on both sides. I always check this because sometimes that can be a gotcha. In the small toolkit are the screws we need, as is the hex driver. The screws have been pre-pasted with some kind of thread lock. As with all of these types of assemblies, once you get it in the hole, it slips in quite easily. When building machines like this, I like to make sure that all the screws are part of the way in before I tighten them off. This can often mean it's easier to line up later screw holes than if you tighten them all up upon insertion. Because I have to do the other end of the X-axis, I'm only going to do these up kind of finger tight, as we'd say. I'll come back afterwards and tighten them all up when the other end of the X-axis is installed. There's already quite a bit of tension on the part. I raise it up so that the screw holes are now aligned. For difficult screw holes, sometimes using your fingers can be an easier option. You can feel when the threads mate, and it's a lot easier than using a hex driver sometimes. Machine threaded screws should go in really easily, so if you meet any kind of resistance, then possibly you've got the wrong screw, or you're trying to put it in the wrong hole. With the X-axis installed, we can put our laser assembly back onto the machine. The assembly instructions inform us next that we need to take the machine out of the foam. I'm seriously running out of space here, and halfway through picking this up I realised I hadn't locked the laser head in place. We'll come back to the air assist pump a bit later. Of course, if you're doing this, make sure you lock your laser head in position. Otherwise you'll look very silly in a video, like I just did. Impressions of the machine so far, for me, are very good, but then again I'm a novice, and the quality seems excellent. Next we must tighten the bolt. This is the bolt in question, and it needs to go into the hole on the x-axis where it will marry up with a belt tensioner. The belt tensioner has a machine thread, and by tightening and loosening this bolt we'll be able to tighten or loosen the belt inside. The only problem is, we can't reach the belt tensioner. So I have to put some pressure on this locking screw in order to bring the belt tensioner closer to the hole. Once I've done that, I find the thread pretty easily. I'm blessed with a brain that really likes absolutes, so I'm afraid when you have things which are analog like belt tensioning screws, it kind of makes me worried. In the end I just settle for something that seems tight enough. Having locked off that belt tensioner adjustment, it's time to look at the belt tension for the other axes. Even out of the box it seems okay, but let's check out how and where we would adjust these belts. On the back we can see two tensioners, one on the right and one on the left. They're identical. I set roughly the same tension on each side, then locked off each of the position bolts on the red section of the machine. The laser is really coming together now. There's just a few more things to do before we're ready to burn stuff. Weirdly, it wants you to fit the feet after you've done all the other stuff. I'm really not sure why. Surely this would make more sense if you did it at the beginning, before you've installed the x-axis. Or perhaps I'm missing something. The feet simply screw into the four positions on the underside of the frame. And with the feet in place, it's time to attach the Wi-Fi aerial, another denizen of that small toolbox which we saw earlier. And with a snap of editing magic, the machine is upright again. I like that you can lock the machine off with this set of keys. This would really come into its own if you were using the laser in a shared space or somewhere where you didn't necessarily want people to be able to turn it on and start mucking around. Amateurs. A bit like me. Okay, let's see what's next in the manual. We need to attach the laser shield. This is magnetic, so it should just snap onto the underside of the laser assembly. And I'm assuming that these are the magnets. But I've spotted a problem. There seems to be a crack in the glass. I can only assume this is some kind of shipping damage. But I'm sure it's okay to proceed with it as it is. Cosmetically it's a shame though. The laser shield attaches with magnets, and that's really torn it. Did you see that? The relatively minor shock of attaching the laser shield to the laser assembly has caused this glass to crack all the way through. And it is glass. I can only imagine it's some kind of diachroic filter. Shame. I'll reach out to AlgoLaser and ask them about this. But, I was about to say it's not a showstopper and will be safe to continue, but now we don't have any filter at all. It's dropped underneath the machine. This is absolutely terrible luck. After some deep consideration, I've decided to tape the glass back into place using this polyamide high temperature tape. Once it's been on for a while, it really sticks quite well. I'm going to use a strip for the top and a strip for the bottom. Let's see how that looks now. well, it looks ugly, but it will mean that we can continue looking at the machine in this video. I bet all the health and safety enthusiasts are going bananas right now. Well, that's it. We're up to how to use, and let's put that manual to one side for now, because we've still got to install this air assist pump. Let's have a look at the air pump manual. Okay, I've read the manual, and the pump is very simple to install. You just place it on your tabletop on top of these anti-vibration feet. I'm not sure what this threaded mount here is for. The hose we saw earlier just push fits onto this output. Let's do that right now. First thing we need to do is take the hose out of the bag. The end without a connector needs to push fit onto the air assist pump. It's a pretty tight fit, so I think just pushing this on will be fine. I'm not sure if this is what the cable ties are for, but I really don't think they're needed here. The other end of the hose has a push fit connection. These push onto a pipe and grip on using a set of teeth that you can only release by pushing in the black collar. The hose is located underneath the left hand side of the machine, and once you've pushed it on, it's not coming off easily. For power, there's a small DIN connector on the other end of this power cable, and in the middle there seems to be some kind of power scale, from 10 to 100, so I imagine that's percent of air. It looks a bit like an S-video cable, but the pinout is totally different. This sure is a wobbly table. The air pump takes its power from the main laser unit, which is supplied by this 24-volt brick. Removing the air pump connector for a second, we can then see the input jack for the 24 volts underneath. Let's quickly slip it in. Then we'll be able to slip the other one into the other socket. Snug. This is for connecting to the computer, and this is for reading memory sticks. Let's plug it in, plug it in. Power on. Okay, bit nervous, but let's do it. Ooh, lights. Rainbow lights, huzzah! And immediately it goes orange and starts to flash, which the manual says is telling me that there's some information. Pressing this bell shows us that the emergency stop is active. The emergency stop is this button here, and by twisting it we can release it, and it handily goes green. We can now clear those messages. And I think we're ready to go, but first it's time for a satisfying peel. Oh yes. That felt good. And this is where we hit a problem. You see, I could connect to my Wi-Fi, if only the virtual keyboard included the ampersand, because my password has got an ampersand in it. I was stuck, so I tried downloading a tool to allow me to set this using my computer, but that didn't work on this model, so USB connection it is. I also had to go and buy one of these separately. This is a Honeycomb Grid, and it's meant to stop you scoring your desktop or workbench. Although I think with the laser it might just go all the way through and do that anyway. But let's shove it underneath the machine and see how we get on. But one other thing. Because I don't trust it, I've decided to cut this large piece of cardboard, which I'll place on the desk to try and minimise any melting of the plastic table. I really don't want to melt my table, I quite like it. Okay, I'm going to place the grid here, and then I'm going to move the laser cutter on top of it. I'm mainly moving the whole thing towards the left because it's closer to the window. I've got the distinct impression that this could get very stinky very quickly. Stop sniggering at the back. I think the first candidate for a test burn will have to be Mr. Wonky Woodsheet. Yes, he's wonky and he's warped, but I do have a solution. And that solution is in the form of some very strong magnets. I'm hoping that these strong magnets will hold the wonky warped wood sheet down to the bed, which is magnetic, ensuring that it's in the focal range for the laser. This could go horribly wrong though, so yeah, watch this space. Anyone familiar with my channel will know that I'm not prone to hiding my mistakes, so if this is a mistake, get ready to see it, warts and all. I'm putting the magnets on before I put it on the bed because, well, frankly, they're really strong magnets and it's quite difficult to get them to do anything near the bed. With the sheet prepped, let's pop it on the bed. Trying to keep it as square as possible, of course. And this side is really popping up until we push the magnet down, and I think that holds it quite well. Now obviously anything we cut is going to come out warped, but this might be good for our inaugural test burn, so we don't waste anything, well, worthwhile. I do have a worry about fumes, so I've brought in this Cyclone 4-inch twin speed fan. It's got quite good throughput, so I'm hoping it can give me some good suction. It has a powerful effect on my curtain. Woohoo! Now of course we don't want to just blast the fumes at the curtain, so I've got a tube. And that attaches onto there, and of course behind the curtain, like any civilized human being, I have a window which I'm going to vent this out of. Let's pop the other end out of the window right now. Off into the English sky. Out of an abundance of caution, I'll also be wearing this respirator mask. I use this when sanding and painting and it really does do a good job. Speaking of caution, I'll also be wearing these laser protection goggles. I really hope they'll protect me against the laser in this unit, but I only have trust to go on. We need to set the focus on the laser and also set up the laptop so that we can burn something meaningful. Connecting to the laptop is just a matter of connecting the USB-C into the side of the laser and the USB-A into the side of whatever computer you're using. Setting the focus on the laser is achieved using a very simple mechanism. By sliding this lever down here, you create a small depth gauge. This should be the perfect distance away from the material that you wish to engrave or cut. Of course, you can do this whilst the laser head is installed on the X-axis, but I just took it off so I could show you more clearly. When you're at the right height, just flick the lever up so it touches the magnet and locks the head in the perfect position. Then pressing the black button makes the depth gauge retract. That's really easy. Something that isn't so easy is getting your head around the software. I'm trying Lightburn for Windows. It's paid software, but it does come with a 30-day free trial. Having installed the software, the laser was automatically detected. Through this, the software knew the working size of the laser attached, but I did have to fill out some questions and give it a meaningful name rather than laser GBRL. It also needed to know where the origin was, and that's where your laser lives when it's not burning things, so ours is the front left. With a few clicks of the mouse, I think we're set up. Now I'm not pretending for a moment this is some sort of tutorial. In fact, I'll admit I don't really know what I'm doing. I just want to show you what my experiences were. This first burn is actually a test chart which I found in the software here. What's meant to happen is it will burn a grid of squares with a playoff between speed and power. From that you should be able to determine what the best speed and power trade-off is for the material that you're using. Unfortunately, it all went a bit wrong for me. For a start, none of this lettering came out on the chart, and I was just left with a very small amount of squares, of which only 3 or 4 would actually pop out of the material. Now I'm not entirely sure that that's correct for this laser, not one that's rated at 20 or 22 watts. Undeterred and refusing to read the manual, I decided I'd do something a bit more sensible, and dragged this picture of former British Prime Minister Clement Atley into the software. The burn that I attempted, well, it was too light, and I realised that's because I set the laser at 20%, and that isn't 20% for burning, it was 20% maximum, so it used that as its ceiling level, and anything below that was kind of shifted downwards. All the darks were, well, not very dark, and all the lights were incredibly light. You're going to see a lot of speeding up from now, so don't worry, you won't have to sit through mind-numbingly long burns. Although it's light, you can kind of see who it is. It actually looks a bit better on the camera than it does in real life. Not half. Although I know that the 20% limit was wrong, I'm also wondering if it's slightly bowed in the middle and changing where the laser strikes the board. So I think we'll try a different material and see if we can get a better image. And in case you were wondering, there is some burning on the grid. And that's from the test chart that we did earlier. It doesn't seem to have gone through to the cardboard though. I have a pack of 100 by 100mm square pieces of thin wood. I thought these would be quite good for testing. Although they're so thin, they're actually a little bit warped themselves. Seems to be a theme here. Foregoing the use of magnets, let's just place it straight on the honeycomb bed and see how we get on. On this attempt I set the laser to a maximum of 60. And we can immediately see that the darks are much darker. In fact, the biggest problem is that everything's too dark. There are image processing and tweaking options in the Lightburn software, so it's worth looking into those. But for now I think we'll move on to something else. Okay, Sid? After that I decided to embrace my inner superhero and cut myself a batarang. But it didn't go very well. I got the power wrong and barely scratched the paper on the surface. So I flipped it over and tried again. This time at 100%, filling the room with plumes of smoke. Thank goodness for that extractor fan. At the maximum setting it definitely went all the way through the acrylic. But there was another problem. The laser had definitely melted through the material, but when it came to removing the item from the sheet, unfortunately it seems that the laser had also fused the whole sheet back together. And I ended up snapping it. My theory here is the more powerful setting on the laser probably overheats the acrylic, causing it to bubble and fuse back together. I'm not sure though. I decided to try again on the piece of the material which I hadn't already used. This time I knocked the power down to 60, but I set it to do 2 passes. There was a lot less smoke. I'll speed this up now so we can get to the end and you can see what difference it's made. Now I've only been cutting the materials in the box, so I'm assuming they're okay, but do bear in mind you can't laser cut everything. In fact, some things will produce toxic chemicals when you fire the laser at them. In fact, you don't want to breathe any of this, but you know, just be careful and check that what you're doing can be cut with a laser. Always work in a well ventilated space and have breathing apparatus on hand. Now I'd say that that is a bit more successful. Batman rising from the smoke. I was hoping for a satisfying peel, but having got this stuff off laser cut acrylic before, I can tell you that's probably not going to happen. Nope, it's more of an awkward peel. That being said, that's quite a smart thing. I think I've probably used a bit too much power, hence the rough edges. Believe it or not, at this point it's about 4 o'clock in the morning and I was still mucking around with the laser. Having got to grips with the software a bit better, I decided to try and make some more little knickknacks. I decided for the time being to stay away from photographic images and try more pixel art stuff. This is everybody's favourite Codemaster's egg, Dizzy. Now I used a bit too much power on this, but I really like the way that it's kind of given different depths to the different greys. At this point I was starting to feel like I was getting the hang of it, so I jumped over to Photoshop and created a coaster in that. Everybody's favourite survival horror, 3D monster maze. I sized the design at 850mm high and wide at 300 dpi. When I dragged it into the Lightburn software, it came up at exactly the correct size and fitted the material perfectly. You can't say fairer than that. Again, I think I might have set the laser power a little bit too high for this cut line. The one thing I've learned is that laser burning and engraving isn't a science, it's an art, and one that you can only pick up over time. So at the end of this video I'm a little bit shaky about how I feel. On one hand I'm not sure about the safety aspect of having an open frame laser, but on the other hand I certainly had a lot of fun playing with it. Big thanks to AlgoLaser for sending this machine, and thanks to PCBWay who sponsor my channel, along with all my wonderful patrons, and they keep me going. Here are my patrons appearing on the screen right now. Look at them, they're amazing. If you'd like to join their ranks and help me make future videos, visit patreon.com/MarkFixesStuff. Not only will you get ad-free early access to my videos, you'll also get access to any blogs that I put out on the platform. It will also make you a better dancer, and who doesn't want to be a better dancer? Thank you so much for watching. Why not go and watch one of these other videos now? Go for it.